Okay, so for day 2 of 4.1, we're going to look at end behavior. And we have 2 goals today. Our main goal is to be able to identify end behavior. Just the same way yesterday we practiced identifying degree, leading coefficient, constant term, total number of solutions, max number of turns. Today you'll be able to tell me what's happening on the far ends of your graph. And then we're going to put all that information together to help us graph polynomials. Okay, so notes 4.1, day 2, we're talking about end behavior. First, I'm just going to have you write some definition of what end behavior actually is. So mathematically, end behavior is described as direction a graph approaches as x approaches the far right or the far left. So a lot of stuff can happen to a polynomial. It can go up and down and curve and things like that. But what we're focused on is just the very, very far ends, the far right and the far left. And somewhere in the middle, I might go up and down and turn, max and min, okay? You know, who knows? But I really, right now, I'm only caring about what's happening over here. Okay. Now, we're going to see some math notation. And then we're going to put that math notation into words. See if this will work. So we're going to make a table. We're going to have 4 sections in the table, 4 pieces of information. And we're going to do a formal math notation, how mathematicians would write out the information for end behavior, and then what that actually means when we see it or when we read it. Okay. So I want you, like when you're doing your homework, the first 4 questions will be end behavior questions. I want you to practice both. I would start with the meaning side, like what is it in words, and then try to write it in its math notation. Okay, so try to do both on the first 4 problems of your homework. The first formal notation we're going to see is x with an arrow and infinity. And that just means the right side or the right end. In red, I've written how you say that. So when a mathematician writes this symbolic notation, we read that as x approaches infinity. Now we have to have the same sort of notation, but we have to show that we're working on the left end of our graph. So then we're going to change our infinity from positive to negative. As x approaches negative infinity, we're talking about the left end of our graph. Think about a coordinate plane. You have an x and you have a y axis. And if x is approaching positive infinity, the positive side is to the right. So we just keep going further and further to the right. So this is x approaches positive infinity, the right side of the graph. If you have x approach negative infinity, negative x's would go to the left. And so you keep going further and further left. So this side is x approaches negative infinity. So they're just saying the right side or the left side of the graph. That's all that notation actually means. Now, to talk about our polynomial, we want to know, what does the polynomial do on the far right or the far left? Is it always going up? Or is it always going down? So we want to talk about what's happening with our y values. Okay. So our first formal notation for end behavior is f of x approaches positive infinity. If f of x approaches positive infinity, that means that side of the graph is rising. It's going up towards positive infinity. Okay. So over here on our graph, we could say that positive infinity, f of x approaches positive infinity, is towards the top of the graph. What is f of x really? Just a fancy way to write y. So we could also think about this as y approaches positive infinity. And so you could kind of guess what the last one's going to be, right? F of x approaches negative infinity, and that means that side falls. You can also write that as y approaches negative infinity. They will be the same thing. And on the graph, that would be down towards the negative y's. So at the bottom of the graph. Okay. Now, most of the time, you'll hear me use the phrases rise and fall, because I think those immediately are going to give us a picture about what's happening with our graph on the ends. Okay, but like I said, when we do the homework, I'd like for you to practice also the notation of infinity and negative infinity. So how do you determine right and left end behavior? Next step, we're going to write the rules, so make sure you have this in your notebook. Let's start with right end. I always tell students, do the right end first. To determine right end behavior, you are going to look at the leading coefficient. And we talked about leading coefficient yesterday. If the polynomial is written in standard form, the leading coefficient should be at the very front of the polynomial. You're going to look at that leading coefficient and you're going to check, is the leading coefficient positive or negative? If the leading coefficient is positive, the right end rises. Intuitively, that makes sense. A positive leading coefficient would mean something goes up. Okay, so the right end rises. If the leading coefficient is negative, the right end falls. Okay. So the leading coefficient only tells me information about right side end behavior. Okay. Rise or fall. To determine my left end behavior, instead of looking at the leading coefficient, I'm going to look at the degree. So see how knowing these parts of a polynomial from yesterday are going to be really important for today. You can identify what the LC or the leading coefficient is, and you can see immediately what the degree is. The degree, remember, is the highest exponent of the polynomial. You're going to check to see if the exponent is even or odd. One of the biggest mistakes in all my years of teaching that beginner students will make with end behavior is they'll ask the same question for leading coefficient and degree. They'll say, is the leading coefficient positive or negative? They'll do the right end behavior. And then they'll look at the degree and they'll say, is the degree positive or negative? What's the degree always going to be if it's a polynomial? It's always going to be positive because you're not allowed to have negative exponents. So you have to change your question. And the question becomes, is it even or odd? If it's even, the left side will do the same thing as the right side. So even doesn't necessarily always mean rise or always mean fall. It depends on what the right side does. That's why we always do right end behavior first. If your degree is an odd degree, your polynomial will do the opposite. So if the right side is rising, then the left side will fall. If the right side is falling, then the left side will rise. They'll do opposite end behaviors. I always like to think about it like odd is opposite. O. They go together. Now, did anybody download the Desmos app on their calculator or on their cell phones? You had, okay, one person. The Desmos app is really helpful because it gives you like a visual of all this polynomial stuff that we're talking about. So I'm actually going to show you Desmos on the web. And we're just going to make up a polynomial. I'll ask you guys for the terms. And we'll see what happens. We'll see what happens and if it follows the same rules as our end behavior. So if you go to desmos.com on the internet, you get to this website and you have to launch the calculator. But if you have it on like your smartphone or your iPad or something, it'll have a little bit different interface. But there's like this sidebar where you can plug in your functions. So we're going to do f of x equals. And then Cole, can you give me a term for a polynomial? You can't think of any term? What does a polynomial look like? Bailey, can you give me one? He got shy.
6x squared.
6x squared. Okay, Jace, you got another term?
2x to the third.
Plus 2x to the third or minus 2x to the third?
Fourth.
Minus 2x to the third. Damon, you got a term for me?
I guess plus 3x.
Plus 3x. And then Cole, can you give me a constant, any number without an x? 2. Plus 2? This is positive. Okay, now I've got to scroll out a little bit to see my polynomial. Here's our polynomial we created. Now let's think about end behavior based on the terms that we got from our classmates. Now be careful, what's not true about our polynomial right now? It's not written in standard form. So if we were to write it in standard form, we would rearrange the first and the second term. So that was negative 2x cubed plus 6x squared. Okay. So this is really the term that we're going to focus on right here in the middle, correct? This negative 2x cubed. Using our checks for end behavior, start with the right end. To check the right end behavior of your graph, you should check if the leading coefficient is positive or negative. Jace gave us what type of leading coefficient? A negative, which means the right side should do what? Fall. Does the right side of this graph fall? Yeah, it's just going down further and further. It's going to go towards negative infinity. Okay. Now we use the second check for end behavior, which is to check the degree. Is the degree even or odd? For negative 2x cubed. Which one is the degree? Ooh, not 2 because it's not in standard form. What's the degree? 3. The highest exponent in the whole polynomial is 3. So the degree is 3, which means the degree is odd. What should the right or the left end do? Cassie says the opposite of the left or the right end. The right end was falling, so the left end should rise. Is that what the graph is actually doing? Yeah. So we could pick random polynomials, plug them into Desmos, and verify that like they're going to do the same things that our check said they would do. Okay. We'll do a couple quick examples, and then I'll have you work on some problems with the partner. Okay. So we can do right and left end behavior, and I'll actually, let's just get rid of a couple of these so we don't have so much. We'll get rid of torture. Why? Okay, computer. Ugh. Okay, let's talk about f of x right here. Okay. Is f of x written in standard form?
Yes.
Yes, 3, 2, 1. It's the same one we had yesterday. What's the degree of f of x? What's that? Oh, the degree is the highest exponent. 3. What's the leading coefficient? 2. Okay. Does the right side rise or fall? The right side will rise because the leading coefficient is positive, and the left side will do what? Check your degree.
Fall.
Jay says fall because it's odd. Okay, so I could say rise and fall. What I want you to do on your homework tonight is also practice your mathematical notation. So you could say, as x approaches positive infinity, then f of x approaches positive infinity. As I go to the right, my graph rises. Okay. For the left side, as x approaches a negative infinity, that's left, then f of x approaches negative infinity. That's fall. Remember, we're only focused on this very first term to determine our left and right end behaviors, because that's where we, in standard form, will find our degree and our leading coefficient. So next up, I'm actually going to have you work with a partner, and so I think I have to move. Okay. When I ask you to graph a polynomial, we're going to be making a sketch of the graph of a polynomial. So if you downloaded Desmos, Desmos is a great app for you to have to make a visual connection to the mathematical function that you're seeing. So you can see end behavior and you can see y-intercept. And it's also really nice for these graphing problems because if after you graph, you could plug this into Desmos and see that your graph is fairly close to what Desmos gives you. The key piece here is our graphs are not going to be exact because in order to make an exact polynomial graph, we'd need a whole heck of a lot of points to figure out where everything is. So we're going to get a general sketch of the polynomial based on 3 things: end behavior, y-intercept, and maybe 5 additional points. You can do more if you're unsure.
Is 5 negative 6?
No, it just means 5 to 6 additional points.
Oh.
So I'd say a good number of points to make in a table of value is about 5 to 6. I'll go with 5 and I'll show you which numbers I choose for x, which will be good numbers for your homework assignment, but you could certainly choose anything. So we're going to do one example. Yeah?
So for the end behavior, would you graph both the left and right?
Yes.
So it's both of them together?
You'll do both end behaviors. You'll make sure your graph follows what you said it should do. So you're going to see that when we do this example.
Okay.
So we're going to graph f of x equals x cubed plus x squared minus 4x plus 2. Now, I wanted to find 3 bits of information for my graph. First off, I just want to get my end behaviors. And for these end behaviors, I'll use the words that make sense to us: right, left, rise, fall. Could you show me the right end behavior for this polynomial?
Right.
It's going to rise. Why did you know it was rising, Jackson?
Because the leading coefficient is positive.
The leading coefficient is positive 1. Okay. And the left end does fall. How do you know it falls? Because it has an odd degree of 3. Okay. So we are just going to hone that skill of identifying degree and leading coefficient. What's the y-intercept of this polynomial? It's at 2, and you saw in that activity, I always wrote my y-intercepts at 0, 2, because it's really an ordered pair. And then we're going to create a table of values with maybe 5 extra points. Okay. And I'll tell you, for your homework assignment, if you choose the following 5 x's, you'll generally get enough of a good picture to graph the polynomial. So I just choose -2, -1, 0, 1, and 2. Now what you're going to do with those 5 x's is you're going to plug them into the polynomial and see what you get out for y, or f of x. If you have a calculator can be an excellent aid. The only thing you have to be really careful of is when plugging in the negative numbers, you need to put them in parentheses before you use an exponent. Okay. I'm going to do the first 2, the negatives, by hand. So I'm going to do f of -2 right up here. And that means I'm just going to plug -2 in everywhere I see x in the function. So I'll have -2 cubed plus -2 squared minus 4 times -2 plus 2. Then I'm going to figure out what is -2 times itself 3 times. -8. What is -2 times itself 2 times? +4. What is -4 times -2? +8. And then +2. And so I'm doing my exponent work right there. I'm doing -2 cubed is -8. -2 squared is -2 times -2, so +4. And then -4 times -2 is +8, and I've got that +2. Now what's nice about this one is -8 and +8 are going to cancel out, so then I really just have 4 plus 2, which is 6. So when I plug in -2, I get out +6. If you have a calculator and you want to try typing that all into your calculator at once, just make sure you're using parentheses so that you get +6. I'm going to do the same thing for -1. So f of -1 is equal to -1 cubed plus -1 squared minus 4 times -1 plus 2. I'm going to follow my order of operations and evaluate the polynomial, so I'm doing exponents first. A -1 times itself 3 times will still be -1. A -1 times itself will be +1. -4 times -1 will be +4, and then +2. And this one works out again. I got 2 things that are opposite, so they're going to cancel, and I still get 6. Oh, that's interesting. We'll see how that works in our graph momentarily. Now, I already know what I get when I plug 0 in, because I already found the y-intercept. 0 gives me 2. Now, just to kind of wrap this up and get our extra points, I'm going to do the last 2 in my head because I don't have that negative, so it's a little bit easier. 1 cubed plus 1 squared minus 4 times 1 plus 2. That'd be 1 plus 1, that's 2, minus 4, that's -2, plus 2 is 0. So when I put 1 in, I get 0 out. If you have to write out the work, you can write out the work. If you have a calculator, you could use a calculator to evaluate. Plug in 2. 2 cubed is 8, plus 2 squared is 4, so that's 8 plus 4, which is 12, minus 4 times 2, so minus 8, 12 minus 8 is 4, and 4 plus 2 is 6. Again, 6 is a popular number here in this function. Now, I have gathered 3 bits of information. I have the end behavior, I have my y-intercept, and I have 5 extra points. Well, really 4, including the y-intercept. So I'm going to put these things on a graph. -2, 6. -1, 6. They're right next to each other. 0, 2. 1, 0. And 2, 6. I didn't make any tick marks, but is everybody okay with my general areas of points? Just kind of estimating them. Okay, now your brain has to fill in the extra space. But your brain knows what happens on the left and the right side of the graph. So on the left side of -2, what's the left side of my graph doing? Falling. So it's coming from the negative infinities, right? So it's going to come up. It must turn around somewhere so that it comes back down. And then it's going to go through my y-intercept, hit that other point, and my right side should do what? Rise. Does this picture follow what my end behavior says? Yeah, my right side rises, my left side falls, and it goes through all the points. So that's a sketch of the polynomial. Now, everybody's might not look exactly the same. Someone else, I'll draw this one in green. Someone might draw it so that it crosses through and it goes really high, and then it comes down, and maybe it actually crosses and then comes up. Is that also an acceptable drawing? For what we have, yes. So that's where I say, you're drawing a sketch of the polynomial. It won't be exact, but it should have like some of the same characteristics in terms of end behavior, y-intercept, and a few extra points. If you put that into Desmos, Desmos should give you a similar picture. And so if you're worried about your graphs on your homework, you could go on the computer or go on the app and type that into Desmos and see if your graph looks kind of like what Desmos gives you.
When you plug it in, would you put in the x and the y, or would you just leave the x cubed plus y? Like, would you add?
Oh, no, you would plug it, you would leave it as x cubed. Yes, you'll do x into Desmos. Don't put a number in there.